Hello, I'm Thomas Hudson and this is our work on MuLD, the Multitask Long Document Benchmark. So MuLD is a benchmark about long documents and multitask learning. It's a set of 6 tasks such as question answering, translation, summarization and classification, where the input consists of at least 10,000 words, and the output ranges from a short single-word classification label all the way up to outputs longer than the input text. So first a bit of context. As many of you will be aware, large language models based on transformers have changed the way we do NLP, and are the go-to approach for many NLP tasks. A lot of this progress has been driven by competition on influential benchmarks such as Glue. There is a bit of a problem with transformers though. While this works well for a few sentences or even a few paragraphs, the attention mechanism, which gives us all this power, gets expensive both in terms of memory and computation time when we want to start to process longer and longer documents. So in the last few years, modifications of the basic transformer have been designed to address this problem. Longformer, reform and linformer are just a few examples. These efficient transformers use various tricks to reduce the complexity of the attention calculation, allowing longer sequences to be processed. These have mainly been evaluated on artificial benchmarks, and the limited real-world evaluation only uses a few thousand tokens, which we argue is more like short essays, while tens of thousands of tokens in documents such as novels are true long documents. This figure here shows us how much longer the documents used in this benchmark are to other long document tasks used in other works. Some of our longest documents are almost 500,000 tokens long. So let's get into the tasks in more detail. There are no new tasks here, they're all based on existing short document tasks that we've modified in some way, either by extending documents, using different data sources, or filtering out shorter documents. And there are a few principles that we use when picking our tasks. The first one is obviously long input size. It must be over 10,000 tokens as we discussed before. Secondly, we want a variety of dependency on the input. Some tasks may require analysing the whole text at once, and others might just need selecting a few relevant sections. For example, in summarization, a model must have a holistic overview of the document, while in other tasks such as question answering, the answer can often be given by just referencing a few relevant sections of the document. In reality, most tasks fall somewhere in between these two extremes, and we want to try and capture a variety of dependencies in our benchmark. Thirdly, we want a variety of output lengths. So while the input length should be long, there's a range of different possible output lengths from a single word classification label all the way up to an output of equivalent length to the input. And finally, we want all our tasks to be easily evaluated. So we pick tasks where the performance can be easily measured using multiple automatic metrics. We do acknowledge, however, that for some tasks, the current metrics used on short documents don't fully capture the challenges that long document evaluation poses. So let's have a look at the tasks in detail. So the first one is narrative QA, which is a question answering dataset based on user submitted questions about the plot of movies or novels. So this was created by giving annotators a short human written summary of the movie or novel, and then they're asked a question about it, and then the model is presented with the full text and is required to answer that same question. And because each sentence that the annotator reads can summarize the plot of an entire chapter or scene of the book or movie, then the model needs to be able to model the dependencies between multiple different sections of the narrative. Because of the nature of the source of this data, it's already quite long. Most of the documents are longer than our 10,000 token minimum, so we simply filter out those which are shorter than this. So our second dataset is Hotpot QA, which is another question answering task. And the idea here is that we're trying to test the ability of the model to do multi-hop question answering, where in order to get the correct answer, you need information from multiple Wikipedia articles. For example, here, the question is asking, are these two individuals of the same nationality, which obviously will require reading the articles of both people. The task is commonly given as a list of selected paragraphs, along with some irrelevant distractor paragraphs, but we expand this to provide the full Wikipedia articles to make this a long document task. So our next task is character archetype classification, where we provide a movie script plus the name of a character and ask the model to classify whether this character is the hero or a villain. This requires the model to have an understanding of the narrative and the character's role in this. This is based on some earlier work for which we replicate the methodology, and because we're dealing with movie scripts, it already consists of long documents. Next, we have a translation dataset based on the website opensubtitles.org, which consists of aligned subtitles in 60 languages, for which we pick English to German. Importantly, rather than just individual lines, the data consists of subtitles for an entire movie or TV show, many of these being very long documents. Style change detection is a task where the aim is to identify where the author changes in a document constructed from the work of multiple different authors. This was part of the PAN series of stylistic tasks, and originally used comments from Stack Exchange threads. We use the same methodology to create a new dataset based on fanfiction stories from the site Archive of Our Own, which are much longer. And finally, we create a version of the scientific papers summarization dataset, where the aim is to generate the abstract given a scientific paper. The original scientific papers dataset removed documents such as theses which it deemed excessively long, and instead we explicitly keep only these documents in order to make a very long summarization dataset. So now we have these very long tasks, what models can we run on them? Well, we experiment with two models, T5, an encoder-decoder transformer which can take up to 512 input tokens, and the efficient transformer Longformer, which uses a sliding window attention to support up to 4096. As our tasks are much longer than these models can handle, we use chunking techniques to divide, solve and recombine parts of the input. For the two question answering tasks, we first divide up the document, then calculate the cosine similarity between the TF-IDF representations of each chunk and the question text in order to score every chunk. Using this metric, we then pick the top 10 chunks and concatenate them together to pass into the model along with the question input. For a simple translation baseline, we split up the document into regular chunks while respecting line breaks, and then we pass in each chunk into the model to be translated, and all the translated chunks are concatenated together to form the translated document. For style change detection, we train the classifier on paragraph pairs with the target of predicting whether the two paragraphs are by the same author. We then follow an algorithm where we assign the first paragraph to the first author, then check if the next paragraph is similar to the first one. If so, we assign it to the same author, otherwise we create a new author, and this continues as we pass through the document. For the character archetype classification, we select chunks containing the first, last and most frequent mention of the character in concern. These are then concatenated and passed into the model and used to predict the class. And finally, for summarization, we split the document into chunks based on the article section headings and summarize the text from the first introduction section of the thesis onwards, ignoring any contents, list of tables, list of figures sections. So what do our results look like? Well, you can see across many of our tasks, Longformer outperforms T5, suggesting it's making better use of its longer context. Notably, the performance of these models on our benchmark is lower than their short document equivalents, suggesting that this is a challenging benchmark and more work is needed devising models which can make full use of the tasks which require very long context. Thanks very much for listening. The data along with code is available on my GitHub, and we've also included the benchmark in Hugging Face datasets, so you can get started exploring the dataset in just a few lines of code.